right, everyone, let's take a look at number 12. So number 12 is a two-way data table, which we actually have not learned this yet this year. We're going to learn it at the end of this week. But you can figure this out without me teaching this to you. So it says a random sample of 200 teenagers, okay? So 200 teenagers total are participating in this taste test, right? I don't know why my highlighter's doing this. Let's circle. 200. Okay, so total, my A, B, C, and D need to add up to 200, and total, my boys and girls need to add up to 200. Each teenager sampled 4 choices of fruit drink labeled A, B, C, and D, and then we're asked to pick a favorite. The table shows the results of this taste test. So of the boys, 45 said they liked A, 25 said they liked B, 30 said they liked C, and 20 said they liked D. Right? Of the girls, 25 liked A, 10 liked B, 30 liked C, 15 liked D. And then you can see the total numbers, right? So 70 liked A, 35 liked B, 60 liked C, and 35 liked D, right? There were 120 boys rather, and 80 girls, okay? So select all that apply. 40% of the participants were girls. Well, 80 out of 200 were girls. So let's go back to our calculator. So we have 80. You should probably recognize right away that this is in fact 40%. But 80 out of 200 is in fact a 0.4 or 40%. So that is true. 70% of the participants preferred A. So 70 of the participants liked A, but that's not 70% because it would be 70 out of 200, which would be 35%, right? But that's not 70%. So 70, not 70%. So this is not true. C, 20 out of 120 boys preferred D. So 20 boys, yes, out of 120 liked D. Yes, that checks. D, 10 out of 35 of the participants who preferred B were girls. So here's B. Of the 35 that liked B, 10 of them were girls. So 10 out of 35 who preferred B were girls. That is true. Okay. And then letter E, the proportion of boys who preferred C is equal to the proportion of girls who preferred C. So the number of boys that liked C is the same as the number of girls who preferred C. And that is not the same as the number of the proportion of boys. So the proportion of boys would be 30 out of 120 liked C, and the proportion of girls would be 30 out of 80 liked C. So although it's tempting, right, 30 out of 60, right, for both of them, so it's 50-50, but the proportion of boys, there's 120 boys versus 80 girls, right? So those proportions are not equal. Just be careful with questions like that because it's the proportion of boys, so the number of boys out of the total. And that is not the same, even though an equal number of boys liked C to girls, the proportion is not the same. Okay? All right, so that's 12. Again, two-way tables are you just reading and interpreting this data, right? Let's look at 13. So 13 says, let the absolute value of x plus the absolute value of y equal c, where c is a real number. Determine the number of points that would be on the graph of the equation for each given case and justify your answers. So this is again an example where we need to justify our answers. So for case 1, c is less than 0. So how many possible points would it be true for us to have c equals 0? Or sorry, c be less than 0, meaning for c to be a negative number. These are absolute value. X would have to be positive and y would have to be positive, which means that c would have to be positive unless x and y are 0, right? And so there are no solutions for this first one. So what you're going to have to say here is there are no solutions for c is less than 0 because the absolute value of x and the absolute value of y would mean that their sum is either 0 if they are 0, or both 0, or positive because the sum of two positive numbers is positive. Okay, so there are no instances in which this number c would be less than 0. All right, how many possible solutions are there for c to equal 0? Well, the only time c could equal 0 is if both x and y are 0. So if both x and y are 0, then c could equal 0. This means there is only one solution of 0, comma 0. And then lastly, so for c to be greater than 0, how many possible solutions are there? Well, I could put any number in for x and y, and it's going to be greater than 0, right? Because x, the absolute value of x and the absolute value of y, they're going to be positive. We add positive numbers together, we're going to get a positive number, meaning it's going to be greater than 0. So that means there are infinite possible solutions for c to be greater than 0 because any value in the absolute value of x and y will become positive and therefore provide us with a sum that is positive and greater than 0. Okay? So again, here is just mostly justifying your answers. This question, make sure that you both know what absolute value is, right? And that you can reason what possible solutions we could have, right? So a solution being a value for x and y that would give us c. All right, let's take a look at number 14 as well. The formula for finding the perimeter P of a rectangle with length L and W is given. So the perimeter is 2L plus 2W. This is one of those equations where a literal equation, right, where we are just, oh no, all right, so I'm not really sure what happened. My sound got cut out, so I'm like laying the sound over this. So sorry about this. Anyway, this is a situation in which we are looking at a literal equation and we're trying to find the length from this perimeter formula. So we're trying to isolate L or length. So I'm going to rewrite my equation and then I'm going to use my inverse operations. So remember we start with addition and subtraction, which means I'm going ahead and go ahead by subtracting here because I have plus 2W. So I'm going to want to subtract 2W from both sides. So I'm going to go ahead and do that here. Subtract 2W from both sides. We get P minus 2W equals 2L, and then 2W minus 2W is 0. Now I can go ahead and divide both sides by 2. So I will get L equals P minus 2W over 2. I'm going to look to see if I have that as solution over on the side. I do. I see that is B. B gives me the length equals P minus 2W over 2. Now if for some reason you look over at your answer options and you don't see that answer option, note that you can also rewrite that equation as 1/2 P minus W because negative 2W divided by 2 is just W. And so if you don't immediately see that equation there that you're looking at as a multiple choice option, you can always manipulate that equation further. Remember that P minus 2W over 2 is the same as P over 2 minus 2W over 2 because they have that common denominator. So I'm going to show you what I mean here, right? We can split that up as P over 2 minus 2W over 2, again, because they have that common denominator of 2. So we can separate them into two separate terms, which would become 1/2 P minus negative 2W, or sorry, minus 2W over 2 is going to be minus 2 divided by 2 is 1, so 1W. Okay? And so you see that we have the answer here, but if you didn't, you can manipulate the equation further. All right, let's take a look at, sorry, I went back over the inverse order of operations. So we have addition, subtraction, division, multiplication, your exponents, and then things in parentheses. So when we are solving for a variable, we are working backwards using inverse operations. All right, in our next question number 15, we are looking at two teams that have obstacle course time. So we have Team R and Team S. This is very close to what we are studying right now, so this should be super helpful for you. So we have the times for Team R in a table, and then we have the times for Team S in a box plot. So kind of summarized data where we have the individual data in Team R. Question A is asking us, how do we represent the times from Team R in a histogram, right? So in this case, we need to look at where the times are between 4 and 5, 5 and 6, 6 and 7, etc. So I'm going to start by looking at between 4 and 5, and let's count how many times are 4s, right? So we have 4 minutes and 25 seconds, 4 minutes and 43 seconds, 4:49. All right, so that means there's three terms or three numbers that are between 4 and 5. And so looking at my chart, I can eliminate C because C has 4 between 4 and 5. Now I'm going to look between 5 and 6 and notice that we have kind of a variation in our three graphs there. One of them, okay, so we're going to do between 5 and 6, count 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. Okay, so let's go down. Our histogram that has 8 between 5 and 6 is A or D. B has it at 7, so we can eliminate that. Let's look now at 6 and 7. 1, 2, 3, 4, 5, 6. So there should be 6. Now, interestingly, all of these graphs have them at 6 for between 6 and 7, both A and D. So let's look at our other ones, right? We notice that the difference here is between 8 and 9 and 9 and 10. So let's look and see how many values we have. We have only one value at 8 something and no values at 9 minutes and some change. So that leads us to believe that the only possible choice for here would have to be D, because we can eliminate B because they have that gap between 8 and 9, and then they have something between 9 and 10. So D represents that the best. Now part B is asking us to analyze and compare the data that we have, that individual data that we have for Team R, with that kind of summarized data that we have for Team S. And it's to select all that apply, which means we need to read each possible answer option carefully. All right, so the first thing it asks us is to compare the median of the data. So if we look at Team S, it's at approximately 7.5. Looking at the histogram for Team R, it's probably going to be between the 5s and the 6s, right? It's going to be seemingly less than 7.5. But we can make sure that that's the case by putting all of our numbers in order from Team R's table. So that's what I'm going to go ahead and do now is I'm going to put them in order starting with my 4s. So I went ahead and circled all of the 4s, which are only 3, and then I'm going to go ahead and put them in order from least to greatest. So 4.25, 4 minutes and 43 seconds, 4 minutes and 49 seconds. Then I'm going to go on to my 5s. So I'm going to list out starting with 5.02 or 5 minutes, sorry, I keep saying point, 5 minutes and 2 seconds. I'm going to look for the next one, which is 5 minutes and 12 seconds. Then I'm going to go to 5 minutes and 21 seconds. Then 5 minutes and 31 seconds. Maybe, there we go. And then 5 minutes and 32 seconds, right? So I'm taking each of the data sets, I'm going to put them in order so that I can find the exact median. Now again, looking at that histogram, I'm going to guess that the median is probably in the 5, 6 range, right? It's going to be less than 7.5, so it seems like A would be true. But I'm going to go ahead and continue to put this data in order so I can know for certain that that is accurate. All right, so I have 6.08. 6 minutes and 20 seconds next. 6 minutes and 26 seconds. I skipped that one by mistake. You'll see later. I go back and I fix that. So I get all the 6s, and then I went to do the 7s and said, oh my goodness, I forgot 6 minutes and 26 seconds. So I'm going to go back and fix that now. See, there she goes. Okay. And then I'm going to put my sevens, 7 minutes and 16 seconds, 7 minutes and 23 seconds, and 8 minutes and 5 seconds. So I have 5 columns of 4 rows. That's 20 data sets or 20 values in my data set. And so that means number 10 and number 11 would be my middle values. So that's 5.5 minutes and 52 seconds and 5 minutes and 54 seconds. That means my median is 5 minutes and 53 seconds as I estimated based on my histogram. So that means that Team R's is going to be less than Team S's. The median is lower than Team S's. So therefore we can eliminate B, right? Then it says the interquartile range of Team R is less than the interquartile range of Team S. So we need to calculate that. So looking at this, the interquartile range for Team S is 9 minus 5, which is 4. That data in the center, right, the 50% that's in the middle is pretty spread out. So my estimation or my anticipation is that that interquartile range for Team R is going to be smaller than it is for S, because that range seems to be a bit smaller. We have between 4 and 8 versus between 4 and 10. We can go ahead and check that by finding quartile 1, which is going to be between 5 minutes and 12 seconds and 5 minutes and 21 seconds. And then the third quartile, which is going to be between 6 minutes and 33 seconds and 6 minutes and 48 seconds. So between those two values, the interquartile range is going to be barely over 1, right? If we're looking at the midpoint of 5 minutes and 21 seconds and 5 minutes and 54 seconds, taking 21 plus 54 and then dividing by 2, it's going to give us a number that's like 5 minutes, and I'm about to actually calculate that for you. So 75 minutes divided by 2 is 37 and a half, so approximately 5 minutes and 38 seconds-ish, right? And then looking at 6 minutes and 33 seconds and 6 minutes and 48 seconds, it's going to be 6 minutes and 40.5 seconds. So again, less than a minute between that interquartile range, right? And so that means that the interquartile range of R is 1 point something, or 1 minute and some change, whereas the interquartile range of Team S was 4, so much bigger, okay? And we can see that because most of the data is towards the center in Team R's. So D says the interquartile range is equal. That's not true. Team S is much greater than Team R. E says the data for Team R is skewed to the left. So if we look at the histogram for Team R, we can see that most of our data is on the left. That means that it is skewed right because less of our data is on that side. So that's incorrect. And then F says the data for Team S includes an outlier. You have not fully learned what an outlier is, but an outlier is when we have 1.5 times the IQR, which I'm going to explain to you now at this point. Not learned the definition of an outlier, but the definition of an outlier is when we take 1.5, the IQR times the IQR, and we add it to sorry, that's the end point. If we add it to the third quartile, is it beyond that? Okay, so, or if we subtract it from the first quartile, is it lower than that? So our IQR here we determined was 4. 9 minus 5 is 4. So 1.5 times 4 is 6. So 9 is our third quartile. So if I add 9 plus 6, I get 15. So anything above 15 would be an outlier. That means that 10 is not an outlier. And then below that would be 5 minus 6, it's quite a lot, which would bring us into the negative actually. So 4 is definitely not an outlier. So there are no outliers in this. And again, we'll go over this outlier piece a little bit later this week. But again, it is we take 1.5 times the IQR and then you add it to the first quartile or add to the third quartile or subtract it from the first quartile. And if it's beyond that point, then it's an outlier. Okay? All right, so that is it. I'm going to pause here, and if you have any questions, again, feel free to reach out to me.